I'm Chandrika. I just explain about the topic of gravitation. Gravitation means the attraction force on the bodies. So first topic, Newton's universal law of gravitation. Every body in the universe attracts the other body with some force, attracts or repulsion with some force. That force, first we can take two bodies, m1, m2. Those are separated by a distance d. So these two bodies are attracted or repelled by some force. That force is directly proportional to product of the two masses and inversely proportional to the distance between them. So by combining these two equations, we can write F is proportional to m1 m2 by d square. So after that, we just remove this proportionality. We using some gravitational constant g m1 m2 by d square, where g is called universal gravitational constant. Where g equal to 6.67 into 10 to the power of minus 11 Newton meter square by kg square. After that, gravitational field intensity. The gravitational field intensity we can define as E bar equal to F bar by m. The gravitational force acting per unit mass m, that is called gravitational field intensity. So we also know about a halo sphere and solid sphere. For halo sphere, we take a halo sphere. For halo sphere, there is no mass inside the halo sphere. So we just take a halo sphere of radius r. So we take a point outside the halo sphere, point 1, which have a mass m. We just have this distance smaller between the center of halo sphere and point P1. We can write outside electric field intensity on that mass, gm by r square, where r is the distance between point and the center of the halo sphere. So at that point there is a mass m. So we have some electric gravitation field intensity at point P1. After that, we take that same halo sphere. Point P2 is on the sphere. So we easily write gravitational field intensity on the halo sphere gm by, in place of smaller we can write capital R square. After that, for inside the halo sphere there is no mass, that's why E inside. For inside halo sphere there is no mass, R, which is smaller, point P3, which is at inside. The point P3 of that mass can be located at the inside of the halo sphere. For that inside, the gravitational field intensity is 0. Because there is no mass, so G into 0 by R square is 0. And we take solid sphere. For solid sphere, there is a mass inside the sphere. First we take a solid sphere of radius r. Point P1 is located at outside of the solid sphere. There is some mass m. So the center of solid sphere and the point P1, distance between those two points is smaller. Then we can write E out equal to the gravitational field intensity at the outside of the point P1 equal to gm by r square. When a point for a solid sphere of radius r, when a point P2 is kept at on the surface of the solid sphere, so the gravitational field intensity between the center of the solid sphere and that point is E on site equal to gm by r square. For last one, solid sphere inside point P3. So have distance smaller, distance of capital R. So E inside is gm r by r cube. When we compare this hollow sphere and solid sphere, those are equal with E outside and gravitational field intensity at point outside and on the surface of the hollow sphere, solid sphere. But inside of the hollow sphere there is no mass. That's why inside gravitational field intensity is 0, and inside gravitational field at the solid sphere is also gmr by r cube. So we can have some derivation for this E inside for solid sphere. So we can actually E inside for solid sphere. We take a solid sphere at a point R, and the solid sphere of radius capital R. E inside for solid sphere is gmr by r cube. So we just consider the field charges. So when a charge just placed inside the solid sphere, Q just placed inside the solid sphere, so we have a distance smaller. So there is a Gaussian surface. There is a Gaussian surface inside. Gaussian surface just created inside the solid sphere. So for this we have Q prime. Initially the solid sphere have charge Q, and the new Gaussian surface, have charge Q prime. Then Q prime by Q. Q prime by Q means Q where charge equal to density equal to charge by volume. So then we can write Q equal to rho into V. Then we can write rho into V prime, rho into V. Rho into V prime means volume of the new surface, 4/3 pi r cube. 4/3 pi small r cube, because of it is a new sphere that have a radius r. Rho into volume of the outer sphere, 4/3, which have radius capital R, pi r cube. Rho cancel, 4/3 pi cancel, that is r cube by capital R cube. So we have Q prime equal to Q into r cube by capital R cube. Then we using a Gauss law, E bar dot ds bar equal to Q by epsilon naught. So we have E into ds bar, 4 pi r square, surface area of the sphere, 4 pi r square equal to Q prime. Q prime equal to Q r cube by r cube epsilon naught. That equal to cancel, equal to Q by 4 pi epsilon naught r cube r. That equal to 1 by 4 pi epsilon naught is k q r by r cube. We can take k equal to 1 by 4 pi epsilon naught. Like this way, it is E bar equal to k q r by r cube. So it is for electric field intensity for charges. When we are taking mass, then we just taken as in place of k constant 1 by 4 pi epsilon naught. We can take gravitation constant. In place of charge, we can take mass as it is remaining those. So we get E bar inside for solid sphere. a circular ring. The circular involves radius r at a distance x. Further, take a circular ring, a point P which is at a distance x from the center of the circular ring, so which is have a hypotenuse under r square plus x square. So we have the electric field intensity at point on these two discs. We have electric field from the center to the point E bar. So which have theta angle. So E bar cos theta. So we just taken the horizontal component E bar equal to E cos theta. Equal to E bar cos theta. Then E equal to, actually we can write E bar equal to F by M. Then Gmm by R square by M. That equal to Gm by R square. Where R is the radius. So in this we can find out the electric intensity at point P to the middle point of the circular ring. So we have distance R square plus x square. So we get Gm by R square. I mean in case of R, we can write R square plus x square. So this is R square plus x square. Cos theta. Cos theta means edges and side. Theta. Edges and side by hypotenuse. X by under root x square plus R square. So then we get equal to Gmx by x R square plus x square whole power 3 by 2. When that point at the center of the ring, then center of the ring, then x equal to 0. When x equal to 0, we get E bar equal to 0. When x equal to R by root 2. So we just consider R by root 2. Then we get equal to Gm R by root 2. That equal to R square plus R by R square by 2. We get Gm R by root 2 3R square by 2 whole power 3 by 2. After that, we have some calculation. Then E bar equal to Gm R by root 2 3R square by 2 whole power 3 by 2. Then Grm by Gm R by root 2 that equal to R3 root 3 by 2 root 2 cancel R square that equal to 2 Gm by 3 root 2 R square. That is the E bar. E bar when x equal to R by root 2. When x equal to R by root 2, we get the E bar value 2 Gm by 3 root 3 R square. Then electric field intensity, the gravitational electric field intensity for circular disc. E bar equal to Gm by 2R square 2Gm by R square into 1 minus cos theta. That equal to 2Gm by R square into 1 minus x by under root x square plus R square. After that, we are taking about gravitational potential. We just have V equal to minus integral E dr. Then we get easily potential. So we have V equal to under Gm by R square into dr. That equal to Gm by R minus Gm by R. Okay. For the gravitation, we just discuss about gravitation potential for spherical shell and solid sphere. gravitational potential for spherical shell and solid sphere. For a spherical shell, we have potential V outside. We just take spherical shell of radius r, point P1 located at outside, which distance of r, then V outside equal to gm by r minus gm by r, because of it have a distance of capital point P2, which is on the surface at a distance of V outside equal to minus gm by capital. After the V inside point P3, which is at the inside, V inside, which have a radius r, V inside equal to minus gm by r. For spherical shell, the gravitational potential for solid sphere we can write V out equal to, when point is at outside the P1 for solid sphere, minus gm by r, on this side gm by capital, and if we just take a solid sphere at a distance of smaller, we have a distance of, we have a radius r, point P1, so potential at outside minus gm by r, and point P2 is just on the surface P2, which have a radius capital R, and it is gm by r. V inside is 2 gm by 3r square, gm by 2r square into 3r square minus r square. 2 gm by 2r square into 3r square minus r square. After that, acceleration due to gravity on the surface of it at a high pitch, variation of g with high pitch. So we just take the mass of Earth m, which is at a distance of r. We just place a small mass m, which is at a height h from the surface of the Earth. So we just find out the acceleration due to gravity of the mass m at a height h from the surface of Earth. So by using universal law of gravitation, F equal to gmn by r square, and from Newton's law we can write F equal to mg. From both the equations combined, we get mg equal to gmn by r square, and then they cancel, g equal to gm by r square. So after that we can write g equal to gm by r square for the Earth. When it is at a height h, gm by r can be replaced with r plus h, total r plus h whole square. Then we can write gh by gm by r plus h whole square into r square by gm. Both are cancelled, r square by r plus h whole square. Then we can write 1 by r plus h by r whole square. Then we can write 1 plus h by r whole power minus 2, 1 minus 2h by r, gh by g. Then we can write last one, gh equal to g into 1 minus 2h by r. gh GH by G equal to 1 minus 2h by R. Then we can find out GH equal to G into 1 minus 2h by R. After the variation of G equal to variation of G equal to F. So we find out the acceleration due to gravity when a point is just below the surface of Earth at a distance of V. We have a earth mass m at a radius of capital R. We just have a point at a distance V below the surface of Earth. So we have density equal to mass by volume. Then mass equal to rho into density into volume. Then we can write mass equal to rho into 4 by pi r2 for total mass capital. For small mass m, that equal to rho into 4 by pi into, so which have radius for this mass which have radius r minus d. So r minus d whole cube. So after that we can write G equal to Gm by r square. Then we can write G into mass m, rho 4 by pi r cube by r square. They cancel 4 by rho G pi r. Like this way we can find out Gv. So Gm by r minus d whole square. We can write G into 4 by pi r minus d whole cube by r minus d whole square. We get 4 by pi rho G r minus d. Then we just take Gv by G equal to 4 by pi rho G r minus d by 4 by pi rho G r. So those are cancelled. That equal to 1 minus d by r. So we can write Gv by G equal to 1 minus d by r. Gv equal to G into 1 minus d by r. At last one, Kepler's laws. Kepler's first law. All the planets revolve around the sun in an elliptical path around the sun. All the planets revolve around sun in elliptical path. This is the Kepler's first law. After the Kepler's second law. Maybe the sun may be, okay, we can take an ellipse. All the planets revolve around the sun in elliptical path. F1, F2. The sun may be situated at the sun may be situated at F1 or F2 foci. The planet just revolve around the sun in elliptical path. For Kepler's second law, the radius vector we just take like this. The radius vector just drawn from the planet to the sun. The radius vector just drawn from the planet to the sun sweeps equal areas in equal intervals of time. That means from A to B. When planet just moves from A to B, or it just moves from C to D, it takes equal areas in equal intervals of time. So that equal to dA equal to 1 by 2 r square d theta, dA by dt equal to 1 by 2 r square d theta by dt, that equal to 1 by 2 r square omega. Then it is constant. 1 by 2 r square omega is constant. Then aerial velocity is constant. Sorry, that area is constant. After that, last one, Kepler's third law. Last one, Kepler's third law. The square of time period of the planet, the square of time period of the planet is directly proportional to the cube of semi-major axis of the planet. The square of time period of a revolution of a planet is directly proportional to the cube of semi-major axis of the elliptical path traced by the planet, where A equal to semi-major axis. So we just take a sun, and around that sun it in elliptical path of one planet revolves. Then we have a centripetal force just towards the sun. So we just take a centripetal force mv square by r, that equal to the gravitational force acting between this planet and sun, that equal to gmm by r square. Those are get cancelled, mm get cancelled, v square equal to gm by r. So further we can write p equal to 2 pi by omega. So we have v equal to r omega. So from this we can write omega equal to v by r. So from that we can write 2 pi by omega v by r, 2 pi r by v. So from this we can write v equal to 2 pi r by t. We just substitute this value in this. 4 pi square r square by t square equal to gm by r. Then we can write 4 pi square r cube equal to gm t square. That equal to r cube is proportional to t square. That means 4 pi square by gm. That we can write t square is proportional to r. So from Kepler's third law we can write the square of time period of a revolution. The square of time period of a revolution of a planet around the sun is directly proportional to the cube of semi-major axis. Cube of semi-major axis of the elliptical path traced by the planet.